Good morning, everybody. So I am Vignesh. I work with Fujitsu as part of the Postgres open source team. So we are adding a lot of features in logical replication and doing defect fixes. We remove a lot of limitations that currently exist. Today I will be presenting a talk on what is WAL, how WAL is used in Postgres. Are you guys able to hear me? It's audible, right? Yeah, thank you. So the agenda for today is we will see what is WAL. So I'll go back to PG7 version many years before, how DML operations were before WAL, then why WAL was introduced. Then we'll see the various components of WAL, and we will jump a little more deep into WAL, see what is WAL segment, what is WAL page, what is WAL record, and then we will see how WAL is being used for various purposes like recovery and replication. Then we will see different WAL levels that are there, and finally we will touch upon how to diagnose WAL information using PG WAL dump and PG WAL inspect. So what is WAL? WAL is nothing but you can consider it as a sequential record of all the changes that is happening in the database. So any change that is happening in the database, we try to write it into the WAL format so that we can recover the data. So we store these files in the PG WAL directory, and we make these changes to the WAL first and then do the changes to data. So that's why we call this process as WAL. So WAL is stored in 16 MB segment files. We'll get into more details in the coming slides. So prior to PG7, we didn't have WAL. So DML operations, we'll see how DML operations happened at that time, right? So all our tables that we have, for each table in Postgres, we have a corresponding physical file present in the disk. So consider we do some insert, update or delete. We will have to read this disk file into shared memory and make the changes in the shared memory. And after that, when we do a commit, right, prior to DML PG7, we will have to go and write this contents to the file, and then commit will finish. So if we have a transaction which operates on hundreds or thousands of tables, so we will have to go and write in random locations in disks, so hundreds of files, thousands of files. So the commit operations were extremely slow prior to DML 7, as synchronous commit had to be done. So if we didn't do, the problem was that if there was a crash, we will lose this data. So we had to flush it to disk. So to solve this issue, Postgres introduced the WAL feature. So what happened was that I'll consider the same use case that we did. So let's say I'm doing some operation on table T1. So I will load the table data from the disk into WAL buffer. So then into the shared buffer, and then I'll make the changes in the shared buffer. And so when we do the changes to the shared buffer, now what we do is we also write the minimal information that is required to recreate the data. So that will be stored in the WAL buffer. So like this, any number of tables changes that is happening, for each of the update operations that is happening, we will do the changes in WAL buffer. So this WAL buffer is a sequential contents. So now when commit happens, what we do is this sequential changes will be flushed to WAL file, and the commit operation is successful. So we have the changes in WAL, and anyway changes are done. we can recover it. So that's the idea. So we have it in the WAL. That's it. So how to recover? I will let you know. So now if any crash happens, any OS crash or it's a power shutdown happens, we have no issues. We have a way to recover this data. Okay. So this was about synchronous commits. In my earlier slide, I told about synchronous commit. So any commit happens, the backend itself will take care of flushing the data to WAL files. So let's say user has configured asynchronous commit. So asynchronous commit, we don't write the changes to disk. So whenever user tells commit, we will immediately, after the changes is done to shared buffer, we will commit the operation. No file operation happens. So the WAL buffer keeps growing. So many transactions will happen. So we will keep changing the WAL buffers. Now somebody should come and write this content to the WAL file. So that's why we have a WAL writer background process. So this is enabled by default. It will be running. He comes periodically, and he will wake up based on WAL writer delay. He will read the WAL buffer contents and flush to disk. So for asynchronous, we do like that. Synchronous backend itself will take care. So no issues, right? Commit record will not be there, right? Abort record will be there. So it will be in the WAL buffer still. So clogs we have where we maintain the transactions status. So anybody querying the database, right? They will see that this transaction is aborted. So this transaction data won't be visible to that transaction. So next we have many components in mainly four important components in WAL. So one is WAL logs, checkpoints, WAL buffers, and log sequence number. So as I told you in the previous slide, we will be writing the WAL buffer contents to the WAL log file. These are called WAL logs. So these are segment files, WAL segment files present in PGWAL directory. Each segment is 16 MB. So after one segment is finished, we will go to the next segment. So we don't write one big file, so that management will be easy. So you keep adding sequentially. So you can remove the old files when not needed. And reading also is faster if you have smaller size files. So that is about WAL logs. Then we have checkpoints. So checkpoints is something like we will have to flush the dirty buffer contents to the disk. So once we flush the dirty buffer to disk, then we don't need the WALs. So that's why checkpoint comes into play for WAL. I'll get into more details about checkpoint slightly later. And WAL buffer, as I told, whatever changes that are happening right on the disk. So we use minimal information through which we can generate the actual data buffer, right? That will be stored in WAL buffer. It's a shared memory. So based on the size specified in WAL buffers, that much memory is allocated. And then we have finally the log sequence number. So any operation that is happening, right, we will add a record to WAL. So this, for each WAL, we will have a log sequence number. You can consider it like an ID in WAL. It's like an offset in the WAL file. So for each of the records, you will see in the segment, WAL records keep increase and the LSN will keep increasing. So WAL segment file is of 16 MB by default. So each WAL segment file is 24 digit length. So we have timeline. First 8 digits indicate the timeline of the system. It's considered, you can consider it like a history of a database. So whenever you recover the database, the timeline will increase. Then we have the file ID. It represents the sequence number for a particular timeline. And then finally the last 8 digits represent the segment ID. It is the segment within one log file. So all these are hexadecimal numbers. So you will see numbers like A, B, C, D. So each wall segment I told you is 16 MB size. So we further break down into 8 KB contents, 8 KB pages. So we have 8 KB pages. So we will have a page header, and for the first page in the new wall segment, we will have a special header, and after that we have the xlog records, wall records, various wall records that can fit in this 8 KB pages, and subsequently then the next page will start. So again we will have wall records. So we saw one wall segment, then wall segment is further zoomed into wall pages, then inside wall page we have wall records. So each wall record, now we'll zoom in and see what is present in wall record. So wall record has three components: wall record header, wall record data, and wall record tail. So in wall record header we will have the LSN, so it's the unique identifier for the record. Then we will have the transaction ID, so the transaction that generated this record. And what is the record type? So like if you have done insert, update, or delete, so that will be mentioned here. And then the checksum for this record. So this will help us in identifying any data corruption has happened. And then in the wall record we will store information about which table's location, and what is the tuple data that is present. And we will have the redo information. So this is a way to generate the data back again using the wall contents. So and in the wall record tail we will have full page image. So this is mainly used for the first modification after the checkpoint. And we also maintain the commit status if transaction is committed or not. So we have various wall record types for various operation that is going on. So when we do a create table, wall record type create will be present. So when we do a insert will be present. So these are self-explanatory. So insert init is a special one. When we do a insert operation on a first time on the new page, we write insert init. So update, delete, truncate, commit are all the same operations that we do. So invalidations is nothing but when we change the system catalog, when we do any system catalog change, we add an invalidation record. So this will help our replication people to know that there is a change in the catalog and update their snapshot. So then we also note down the running transactions. So this will have which transaction is committed and which is the last new transaction and what are the open transactions. So BG writer process writes this periodically. And we have hot update. So if you don't want to do an index update, so we will do a hot update directly on the page. And new CID it indicates the various commands that is going on in a transaction. So let's see now how checkpoint happens and how it helps wall. So as soon as the checkpoint is started, we will write a wall record for this checkpoint. Then we will flush the shared memory contents like C-log to disk, and then we flush the shared buffers. So this is like in my second slide I told you that we had dirty buffer contents and the wall buffer contents. Wall buffer contents we had flushed either through wall writer or through background through the backend for synchronous and asynchronous commit. So now we had a lot of dirty pages changes for the DML operations that was going on. So that will be done by checkpointer. So based on checkpoint timeout that we have specified, checkpointer process will wake up and he will flush the dirty pages to disk. So once we flush the dirty pages, right, so we don't need these WAL record. So we can advance our redo position. So the previous WALs are no more required. So from until here, all these contents are present in disk. Even if system crashes, we have no issues. So redo position will advance, and we write this information into PG control file.
So one question.
Yeah.
Flush it, right?
Yeah.
Flushing only the committed transaction or everything?
We will flush everything. Yeah. So and we have the transaction status. So based on that, we decide. And we have vacuum to take care of cleaning up these contents, so which is not required.
So when you do this one, right? Let's say checkpoint happen.
Yeah.
Will be clearing off all the ones previous one can be cleared off.
So it is not only that dirty buffers requires WAL. Even replication slots also requires the WAL, right? So both, if replication slot also has proceeded further, right, and checkpoint also has flushed, then we will remove it. And oldest active transaction, correct. So these, based on these three, we will.
Only if the transactions are committed, right?
Yeah.
Previous ones.
No, irrespective, right? It is now flushed to disk, right? We don't need the redo.
Not the actual file, only WAL file will be there, right? Not in the actual disk files, right?
Yes. So in disk also, every page will have the where the transaction information, right? Every page has it.
So is there a checkpoint start and a checkpoint end?
Yes. Yeah, we have a checkpoint start and end. So we have a configuration checkpoint timeout. GUC is there. So by default it is 30 seconds. So you can configure it based on your how many transactions are going on, how frequently it is going on, and how you have configured the dirty buffers, what size, right? So based on these, you will have to take a call and it will happen. Yeah, because we will have to write to disk, right? So and parallelly you're doing some select, right? So IO channel is limited, right? So you will have some overhead. So that's why you will have to configure your buffer, the shared buffer, WAL buffer, and checkpoint timeout accordingly, and how many transactions are happening, how many dirty pages will be generated. So based on this, it varies for each system. So you will have to take a call on that. Yeah. Yes.
And in between there might multiple transactions happen and committed.
Yes.
That open transaction yet flush transactions or
It will be flushed to disk.
and then later how we know that the open transaction has been committed and has to be replicated.
We write the transaction commit record also. So we will have the WAL data. So let's say you are inserting 1,000 records, right? 1,000 records information will be present in WAL, and let's say after 1 hour you committed. So for replication also, these WAL content will be sent, right? But only when you do a commit, when you get the commit or commit record, he will apply this transaction in the standby node. So until that, it is an open transaction. If a transaction is open in primary, it's an open transaction in standby also. But WAL record will be there, shared buffer also will be there. Similar thing will happen in standby also.
Okay, in case of rollback we end up sending data but
It will be rollback. CLog will be updated. When you do a query, you will see that this transaction need not be selected. So next we'll see how recovery happens after crash. So I told in checkpoint, right, we maintain what was the redo point. So up to how much data is flushed to disk. So we will read the PG control file. From PG control file, we know from which location we need to replay. So up to recreate the system back, that was before the shutdown or crash, right? So now I know the location. Once I get the location, I will go to the PG wall, corresponding PG wall file. I will read that wall record, and I have the redo function which will tell me how to generate the data back. So for each record I do this, I'll be able to generate back. So in wall itself, we know whether it is committed or not. So similarly, I will apply it. And so it's almost like we have recreated how it was before. So whichever transactions are committed, we will know from the wall commit record, commit those transactions. So there is a catch here. There will be some open transactions. So these open transactions, we cannot do anything. We don't know whether user wanted to commit it or he wanted to roll back. We cannot do much about it. We cannot give the control back there. So there is no way to do that. Only thing is we'll have to abort all these transactions. So system is back now.
The recovery itself is locked.
Is it?
Recovery process also is locked. There are all records.
Yes. Yes. Correct.
So few times recovery happens automatically. Like my system got crashed.
Yeah.
Again, database goes into recovery mode. It says in background this
Whole thing will happens. So we cannot allow the transaction connections immediately because we have to recreate the system to old state. So otherwise you will have some data like half an hour back or 10 minutes back data. So we need to first recreate like to the state the system was. So after we recreate, then we allow the connection. So you can check that recovery is in progress flag. Yeah. Yeah. So yes. So till that time we block the connections. After that we have recreated, then you can start using. So system is back to the older state.
One more thing, you said, right, when we do a flushing, right, flush on pressure,
Yes.
it goes to wall and it goes to disk also, right?
Yes.
Same time. So, and after the checkpoint is done, right, you said you will be clearing the walls.
Yes.
Let's say after this point, right, let's say on restart upload, something crashed.
Yes.
So you'll be looking into wall file, right, for reapplying the changes.
Yeah. So I know from PG control from where I need to, from which location of wall I need to replay. So I will go to wall, the corresponding wall record I know, wall location I know. From that wall location, this wall location is nothing but the last checkpoint's location. So whichever is flushed to disk, right? From that location, we will replay. So those are nothing but reading from the wall.
But you said, right, you will be flushing the disk and wall, right?
Yes.
And after the checkpoint is done, you said you will be clearing all the
Not all. For the pages that we flushed, right? I know the wall location till which these pages were flushed. So there is a link between checkpoint and the recovery. So not all, which is not required, I will remove. Or we have some configuration also, like we can tell keep this much wall segment and based on slot, right? So based on that we decide what to be removed. But definitely whichever is required will not delete.
when you say whichever is required, right?
Yeah.
What is the criteria for that? What is logical application?
Replication slots you have in system,
Yes.
right? Physical replication or logical replication. We maintain the wall slot position, right?
What I want to know is what is the criteria to retain the things in wall actually? Even if you do a checkpoint, right? Manual checkpoint or
So you did a manual checkpoint. Let's say your wall record is at a position 1000, okay? And logical replication and streaming replication, let's say their position is at 100 and 200, right? So we need the wall record, even though we did a checkpoint and recovery needs to be done only from 1000, but still we have wall sender process which will send data to the standby or subscriber, right? They need to send from 100 position. So I will keep minimum till 100. So that information will be there.
you're saying only for the logical application you will retain the wall.
Logical replication, streaming replication, and okay, and we have a configuration like wall minimal wall segment size. So let's say you have configured it to some 500 MB. So that 500 MB data I will keep it, even though replication slots are ahead. 500 MB data I will keep. So once it exceeds 500 MB, then I will delete the older files.
And there's no connection between running transaction and unconnected transaction.
No, nothing. So we will be able to create the snapshot of the database as we read the wall. So periodically BG writer writes and we have commit records. We will update the snapshot. So you will get what is happening in primary. Same transaction status you will get in the standby. So that is about recovery. So we have the system as in earlier state. So I told each WAL segment is 16 MB. So once this 16 MB is filled up, right, I will create a new WAL file. Suppose you feel like after you do some operations, you want to start a new WAL file, you can do a switch. Or if archive mode is enabled, right, and archive timeout expires, we will create a new WAL file. So yeah, let's say I was in WAL 4 and WAL 4 finished, then I will create the new WAL file 5. And based on the conditions I told now, for which it for recovery and replication, let's say WAL 1 is not required, then I will remove this WAL 1.
How will you decide this wall one is not required?
It's the same answer that I told.
I just wanted to know if the max wall size is 500 MB.
Yeah.
But I have seen a couple of times that it exceeds more than 500 MB.
Sometimes there will be a very old open transaction that you have, or logical replication slot is there, or a streaming replication slot is there. See, if a subscriber is down, right, and so the WAL sender cannot proceed, so he needs to retain that. Yes,
So the 500 MB is minimum size, or
that would be the maximum. We also have max WAL slot size also, and if the slot is active, right, we won't delete it because it is required, right. So if the slot is released, then we will delete, and that slot will be invalidated. Yeah.
the archiving is on, right?
Yes.
The wall won't be.
So I have a slide for that. I'm coming to that. So we'll see how WAL is used in streaming replication. So streaming replication allows us to create a read-only instance by replicating the changes from primary node to standby node. So whatever changes that is happening in the primary node, you will have a copy of it in the standby node. So you'll be able to do only read-only operations. You cannot do write operations. And if anytime the primary node goes down, you can make the standby as primary node. So let's see how WAL helps us in streaming replication. So when user performs any transaction, right, so the initial thing is same. We will generate shared buffer and WAL buffer for the transaction data. Then WAL buffer contents will be flushed to disk, and for replication we will have a WAL sender process running. So this WAL sender process will be reading this WAL records, and he will send this to standby node. So in standby, WAL receiver receives the WAL record. He will apply it to the WAL buffers, and we have a startup process which is running. He will read this data and apply the transactions. So now we have the same data that is present in primary is also present in standby. So WAL helped us with this. So this WAL slots, right? So WAL sender will keep updating. He knows up to how much he sends. So if there is too much WAL being generated and the network is slow, right, then there will be a lag. You will see that slot is progressing very slow, but system is generating a lot of WAL files. So under these scenarios, you will see more WAL is present. So similarly, we use it for logical replication. So logical replication, similar to streaming replication, wherein we can select what data needs to be sent to subscriber. And another advantage here is you can also perform write operations in the subscriber. So the top part of it is the publisher node. So when any transaction changes are happening, right? So we will generate wall buffer and flush it to wall. So wall sender reads this wall and sends it to apply worker. So here we send selectively. So selectively to apply worker. Apply worker applies this transaction in the subscriber. So even here we use logical replication slot in publisher node. That's how we'll know what is the wall position up to which how much I have sent, and what wall files should be removed.
Vignesh, one question.
Yeah.
Here we have logical decoding workman.
Yes.
Where we are decoding everything.
Yes.
The question here is that are we decoding every wall that is coming and then choosing which object is there for the replica set? Or we are just decoding the particular object only which we are replicating? Because it is, anyway, we are not doing compute for a optimized compute, right?
Currently it is like we are decoding every record, then we know whether we have the publication, we will see the publication and decide whether it should be sent or not. Current approach is there, but there is some discussion going on, probably in next version or so you will see some improvements here. Yes. Yeah, I agree, I understand. We know we have a few issues, we send aborted transactions also, so all those things, some work is going on, hopefully in coming release. Per publisher you have one wall sender. So if you have two publisher subscriber, you will have 2 wall senders running. You can add it. So after you add a table, you will have to go refresh the publication in the subscriber node. So that will take care of handling the initial sync and then get the incremental changes. So you once you add, you will also have to go to subscriber and refresh this publication.
And about the wall garbage collection, right?
Yeah.
For logical replication slot, if you have say 5 tables subscribed, right? And there are operations happening on the tables which are not subscribed. Then the wall will increase obviously, but the slot doesn't need that.
Yes.
Will it still hold for that slot because it doesn't need any changes for that?
Still it will hold. So only when you decode, you will come to know, and after you decode, you need to move the position.
Then that slot is actually unnecessarily getting reclaimed.
Yeah, this is similar to what Jay also was telling, right? There are a couple of threads running in Hackers to do this. I don't know. So Shlok may be sitting here and he is working on it. So you'll get some updates soon for that.
But these intermediate buffers are flushed. It's not all in memory, right?
Yes, you will configure logical decoding work mem. So let's say you have configured it to 512 MB, right? Yes. After that, it will be flushed to disk, or if you have enabled streaming on, right, it will stream to the subscriber. So another thing that wall is used is, it is used for wall summarizer process. It is mainly used for incremental backups. So here we identify what all changes have happened from the previous checkpoint, and we store it in the summaries directory. So when we take an incremental backup, he will use this contents to do a incremental backup. So this operation is not enabled by default. You will have to configure summarize wall GUC. So if it is configured, it will be used. So by default, the wall files will be present in the PG wall directory. So if you want to take support PITR and all, right, you can use archiving mode. So by archiving mode, what will happen is that whenever we do a switch file, right? So this current file will be copied to archive directory that you have specified in the archive command. So you can do a base backup once and keep taking the archive files. So you archive the files. So then what will happen is you can go back to the database in any point of time. So you can specify what time you want to go, and you can recover the database at that point. So this is a important configuration, sync commit. So we have various options: off, local, remote write, on, and remote apply. So if you have configured it to off, during commit operation, we won't flush the contents from WAL buffer to WAL file. Commit will be extremely fast, but if there is a crash, we cannot recover data. Some transaction data will be lost. So next higher level is local. So by this, during commit, the WAL buffer's contents will be flushed to WAL files. So any crash happens, you will be able to recover it. These three parameters, remote write, on, and remote apply, is for replication. So remote write, what will happen is, apart from writing the WAL buffer contents to WAL file during commit, it will also send this WAL buffer contents to the standby node. So which standby you have configured, it will be sent there. And in remote on, on, what will happen is that apart from sending this WAL buffer contents to standby, we will also make sure that this is flushed to the WAL file in the standby node. So here we are sending the data from primary node, the WAL data is sent. So in the previous case, it was in memory. In on, what will happen is, in the standby node, WAL buffer of standby will be flushed to WAL file. And the last highest level is remote apply. So apart from sending to standby, flushing to WAL file, we also make sure that this transaction is applied in the standby node. So by this, what will happen is, whatever your data that is happening in the primary node, you will see the same data in the standby also. If CRC is enabled, it will detect. You can detect it.
In my case, one of my primary got corrupted. It's got restarted.
Hmm.
That time the WAL files got corrupted.
Okay.
If I enable this remote apply and remote write,
Yeah.
it replicate over there as well.
So you should have enabled the CRC of WAL record. So if it is enabled, we can detect that there is a corruption.
The corruption has happened when my server got restarted.
Okay. So is it because of some disk corruption?
It's not because of this corruption. So just by voice that
Okay.
There are few situations like drive size got filled up. This also I have faced. Drive size got filled up, and after that we increase the drive size from back end of the VM, and after that when the service starts, right?
Yeah.
That's it. The wall size it gives a different error that okay could not detect this wall file data is not.
Okay. So I think only option in this case is you should have taken a backup and you'll have to restore it. So that's why we recommend taking backup periodically.
options like duplication of this WAL files.
You have archive files, right? So
Archive will come into the picture when my WAL file got filled.
yeah.
But how we are
So not when it is filled. Every time we switch from one file to the next file, right? This current file will be copied to the archive directory.
what I'm comparing is like in Oracle we have this duplication version.
Okay.
Same kind of structure.
Currently we don't have anything like that. Yeah.
So when the setting is remote apply,
Yeah.
isn't it too risky, because now if the synchronous standby goes down,
Yeah.
then it will never return to the client.
Yeah. So the commit will wait. So that's why we have configurations, right? Yeah, but if we support this, but let's say you want, okay, sorry. Okay, we'll quickly go through remaining slides. We have few minutes left. So we have 3 wall levels: minimal, replica, and logical. So if you are not using PITR or any replication feature, use minimal. It will generate minimal records to which we can generate the data back. And if we have to support PITR or streaming replication, set it to replica. That is the minimum level that we need. And if we have to use logical replication, set it to logical. So if you use wrong settings, the problem is that it will generate more wall, right? Unnecessarily. Your performance also will go down. So in case of logical, for update and delete, and we have set replica identity full, we will log the whole wall record. So more wall data will be generated. So if you, based on what feature you're using, corresponding wall level should be set.
Which is the default
Replica. Yeah. So we can diagnose, like so corruption happens or something, right? We can get an idea from PG wall dump. So PG, the wall segments that are there are binary files which humans cannot read. We can use PG wall dump to see the contents. So you can see the whole segment file itself, or you specify start and end segment, or if you want to see one particular records, one particular relations changes that is happening. So in database we cannot see the history of the file. So PG wall, through PG wall we can see the history of the table, what and all operations has happened. So you just specify the relation, get the table space, database, and the object ID, and specify it. You will be able to see the history of the table. So we can also diagnose using PG wall inspect. So generally not everybody will have access to the system. So in cloud environment, mostly we will have only SQL access to the system. So use this PG wall inspect extension, and we have SQL queries to get the wall records between the segment or one particular wall record. So all the features that are there in PG wall dump, we have it in PG wall inspect also.
Is it equivalent of log miner in Oracle?
I am not very familiar with Oracle. Okay, so we saw what is wall, how what is the history of wall, why wall was added, then how wall helps in recovery, how wall helps in replication, various wall configuration, and how to diagnose wall. Okay, so we have minimum set of transactions. So you can have 4 billion transactions in Postgres. It's a 32-bit int. So if you have some very old transaction that is running, right? So the wall files cannot be removed, right? And we cannot generate a new transaction. So that's why this problem is there. You will see some error message continuously coming in the system.
Initially, when I asked the same question, right, you said you don't need what was a running transaction, right? This was my question first. What is the criteria to
yeah, I told you, right? One is old transaction, slots, and the configurations that is been. Yeah. Yeah.
In that case, let's say transaction is last 1 hour.
Yeah.
So you need to change the word for the last 1 hour, right?
No, if it is old, if we have a old transaction, right, we need to retain it. Transaction finishes. Yes. Yeah, committed or aborted.
There were a few questions that switches are this.
You have time?
It's like 2.
Okay. Okay, I'll take questions offline. Thank you so much, guys.